What is touch? Touch is the sensations caused by mechanical displacements of the skin. For example, licked by a dog or being kissed by a significant other, etc. It occurs when you make contact with an object. Tactile is another word for touch. Temperature changes, thermal sensation, sensation of pain. Kinesthesia is the perception of the position and movement of our limbs in space. Proprioception incorporates sensory input from locations internal to the body, such as your body and kinesthesia. Somatosensation is sensory signals from the skin, muscles, tendons, joints, and internal receptors. Pain tells the body whether something is happening internally or there is a dangerous external stimulus. Noxious stimuli is stimuli dangerous to the body. Touch can be used to identify an object we cannot see or hear. Where and what are the touch receptors in the skin? Touch receptors are found in the skin, mouth, muscles, tendons, and joints. Touch tactile receptors are found in the epidermis, outer layer of the skin, and the dermis, the layer on the epidermis. These receptors form the basis for multiple channels, specialized information processing subsystems that each contribute to the overall sense of touch. Each type of receptor can be characterized by three attributes: type of stimulation, size of the receptive field, and rate of adaptation. Tactile receptors. Mechanoreceptors, a tactile sensory receptor that responds to mechanical stimulation or pressure. Consists of a nerve fiber and associated expanded ending. Nerve fiber composed of the axon and myelin sheath. A beta fibers, wide diameter myelinated sensory nerve fiber that transmits signals from mechanical stimulation. Glabrous skin is skin that lacks hair. The four populations of tactile receptors are found on the palms. The four populations of tactile fibers are Meissner corpuscle, which is the specialized nerve ending associated with fast adapting FAI fibers that have small receptive fields. Merkel cell neurite complexes, specialized nerve ending associated with slowly adapting SAI fibers that have small receptive fields. Pacinian corpuscle have large receptive fields, FAII. Ruffini ending have large receptive fields, SAII. Meissner and Merkel receptors are located at the junction of the epidermis and dermis. Pacinian and Ruffini receptors are embedded deeply in the dermis and underlying subcutaneous tissue. Tactile mechanoreceptor expands from its terminal to the spinal cord. SAI respond best to steady downward pressure, fine spatial details, and very low frequency, less than 5 Hz. SAII in the skin respond to sustained downward pressure and lateral skin stretch when you grasp an object. FAI respond best to low frequency vibrations from about 5 to 50 Hz. FAII responds best to high frequency fibers from about 50 to 700 Hz. Thermoreceptors located in epidermis and dermis inform us about changes in skin temperature. Two distinct populations of thermoreceptors are warm fibers, which sense a rise in skin temperature, and cold fibers, which sense a decrease in skin temperature. C fibers are unmyelinated sensory nerve fibers that transmit pain and temperature signals. A delta fibers are myelinated sensory nerve fiber that transmit pain and temperature signals. The temperature of the skin is kept between 86 degrees and 96 degrees Fahrenheit. Fibers do not react much if the body is at this temperature. Nociceptors, touch receptors that have bare nerve endings and that respond to various forms of tissue damage or stimuli that have the potential to damage tissue in response to pain input. Two types of nerve fibers, myelinated A fibers and C fibers. Pleasure and touch receptors are discriminative touch, tactile, thermal pain, and itch experiences. C tactile afferents are narrow diameter unmyelinated sensory nerve fibers that transmit signals from pleasant touch.